Welcome to Cornerstone Education. Tonight's webinar topic is water heaters, presented by Stan Bajerski, and I'll hand it over to Stan right now.
Hey guys, thanks for attending this evening. My name is Stan Bajerski. I'm a licensed home inspector in Connecticut since 1989. Today we will be discussing water heaters, basically the different types, what to look for when we do our inspection. Okay, Jim. So it is an important component of the home. If you've ever turned on the shower and there's no hot water, it's like the end of the world, right? So it's something that is out of sight, out of mind, but when it fails, it's a big deal. The last thing we want to do is have to pay for a water heater. So we really, as simple as it is, we really got to look them over pretty good. So today we'll discuss their the common parts, excuse me, of the water heaters and go by the types of water heaters. The most popular will be the tank water heaters. Just a little bit of history on the water heater. We've had hot water since 306 AD. The Romans had baths facilitated with heated water, which can be regarded as a pioneer work for water heating. In 1868, the very first residential water heater, which used natural gas, was developed. The first patent for a water heater was issued in 1889. The first electric water heater was invented in 1892, and the first gas water heater was invented in 1896. So we've been having a need for hot water for a long time. The standards of practice for the three states that we usually talk about, all of the requirements for water heaters and their inspection are embedded in the plumbing system. So they're not a separate component in most states. They are considered part of the plumbing system. In Florida, you're supposed to inspect and identify the water heating equipment, including the energy source, and then you don't have to do solar water heating systems. Next slide, Jim. In Mass, again, embedded in the plumbing section, you have to identify the type of water heating equipment, the nameplate capacity of the water heating equipment, gallons per minute, or gallons in storage. So that whole big plumbing system in one line so far, and same thing with Connecticut. Next slide, Jim. Again, just a little even shorter than one line, water heating equipment, including energy source, location of main water field shutoffs. So they're based on the standards, they don't ask us to do a lot. Is it working, basically, and those things that they want us to identify. So there are common components of all tank water heaters. There's a steel outer jacket that encloses a pressure tested water storage tank. This inner jacket is made of high quality steel with a vitreous glass or plastic liner layer bonded to the inside surface to prevent rusting. Along with that is a dip tube, a tube usually plastic that brings the incoming water, cold water, to the bottom of the tank. So right now my mouse is not working. I don't have a pointer, but on the dip tube, yes. So we're going to bring that cold water all the way down to the bottom of the tank. The hot water, the water tank is just like a house. The water is going to stratify just like air, and the hotter water is going to collect at the top and go out that tube, out that pipe. If that tube deteriorates, where does that cold water go? It mixes with the hot water that's ready to go out. So we're going to talk about this a little later on, but if you feel that a water heater is not functioning properly, there are a couple things that could be wrong, but a lot of times it's a defective dip tube, and that water is just being tempered right at the top of the tank, and you can't get any temperature. Okay, so the dip tube is replaceable, but that's a pretty important part of a water heating tank. Next slide, Jim. Pressure relief valve. All tanks will have one. Temperature and relief actuated valve near the top of the tank or on the side of the tank. It automatically opens and closes to release water when the pressure and temperature inside the water heater exceed its rating. usually 150 psi, 210 degrees Fahrenheit, preventing the tank from bursting. If we have a closed system like a water heater, like a boiler, if the temperature rises, the pressure is going to rise. They go hand in hand. And so that would be usually, if we have an issue with the relief valve, is a thermostat problem most of the time because it just overheats the water, or that valve itself is tired and it's not seating properly and dripping, or a piece of debris could be stuck in there. All right, so again, later on, we're going to see if your pipe is dripping, you got a problem. You don't have to tell people exactly what the problem is, but you really need to call it out. What I do is not only put in my report, but it's a problem for the people living in the house at the time. So I'll pass that information on to them as well, because that could be an issue the minute I step out of the house. They need to know I didn't do anything. That's the way I found it. That's the way I feel anyways. Next slide, Jim. Of course, we need a way to drain the valve. So there are a couple different style of drain valves. The one with the screwdriver is probably the most secure. Nobody can accidentally open that. No kid playing in the basement. The other two probably, if somebody was curious, can open those. And but those are the three basic drains that I see, and they could leak. So if you see that, you would want to, I believe they're all able to be capped as well to prevent somebody from accidentally opening them. Next slide, Jim. And of course, a cold water inlet and a hot water outlet at the top of the tank. The cold water inlet will have a valve on it. And I'm going to say 99.9% of the time, the hot water will not, unless somebody feels they want to have one on there, but it's not standard practice. Okay, Jim. An anode rod is also a common component, and it's basically considered a sacrificial rod. And its purpose is to try and take away the things that can corrode the inside of that tank to make the tank last longer. The anode rods will or can need to be replaced. There are certain things that can happen that would identify that problem. Maybe the average homeowner wouldn't know, but if you see it during a home inspection, we'll be talking about that down the line. You can pass that on. Next. So the types of water heaters. There are many different ways to provide domestic hot water. The most popular method of heating the water includes electricity, oil, gas, and propane. It could be supplied by storage tank style, domestic coils, tankless, and indirect style water heaters. So we're going to start out with the electric water heaters. The electric water heaters use the home's electricity to power the heating elements. There's usually two in the tank, as you can see in the illustration. One up closer to the top, one at the bottom. And we're probably going to say this with each type of tank, that the hottest water will rise to the top. That's the whole idea. And then we bring the cold water down to the bottom. There's a thermostat for each element so that you can adjust water temperature, control the water temperature. Next slide, Jim. There are two different types of elements if they need to be replaced. It is the key to getting hot water. Obviously, without them, you're not going to heat the water. But the lack of hot water is not the only indicator that you may need a new water heating element. So you can also experience rust, noise, and leaks. The leaks usually come from where that screws into the tank. The type of water heater element you choose will depend on voltage, wattage, and diameter of your water heater, but will also depend on if you want to spend a little money, because the low density, there's low density and high density. The low density is more reliable and more resistance to rust, but they are also more expensive. I don't really know the price difference, but you know, some people spare no expense and other people try to go the cheapest way. They're both going to work. It's just one's going to be replaced before the other. I would estimate to say that at least once in the lifetime of an electric water heater, those elements are going to need to be replaced. The low density water heater is made of a couple different materials that are more resistant to corrosion. So that's why they're a little more expensive. Okay, Jim. So the advantages and disadvantages of an electric water heater. Electric water heaters are usually cheaper to purchase because there's really no burner assembly on the bottom. They're just a tank with a couple of elements in them. They're ideal for areas where there's no gas and oil, obviously, and that's what you'll see predominantly. They will generally last longer because we don't have that excessive heat at the bottom like we have with oil and gas. And we don't need a flue, right? No flue gases. So they can be located almost anywhere. Any place you can get electricity and water, you're going to be able to put a water heater. The disadvantages, they're more expensive to operate and they have a slower recovery time. So once you use that hot water or most of it, it does take longer for those elements to get back up to temperature. Next, Jim. So gas and propane. So gas fuel water heater, whether it's propane or natural gas, has a burner system that is ignited by nowadays by a pilot light or electric ignition. And that's how we heat the water in the storage tank. And of course, with all tanks, that hot water goes to the top and we bring in the cold water at the bottom. There is a thermostat usually located on the gas valve where you can dial in the temperature. Flue gases that are generated by the burning of the fuel are going to go through a flue that's in the middle. There's a baffle in that flue to churn the smoke and help it get out up into the smoke pipe and into the chimney. The draft hood helps alleviate the pressure on the tank so that we can maintain a proper rise in the flue gases and not blow out the, if there's a pilot light, blow that out. That flue also helps add a little bit of heat to the water. Okay, Jim. So the advantages, well, they're cheaper to operate than electric, customarily about a third of the cost. Propane's a little more expensive than natural gas, but still a lot cheaper than electric. Gas water heaters recover very quickly. All right, they're better than electric water heaters. If you have heavy hot water usage, you will probably be able to replenish the water more rapidly with a gas water heater compared to electric. So because of that, you're probably going to meet all your needs with a gas water heater. Disadvantage is only the location is restricted because of the need to vent the flue gases. So you need to be near a chimney or an exterior wall. Okay, Jim. Oil-fired water heaters, very, very similar, just different fuel. Oil-fired water heater has a burner system that is ignited by electrodes to heat the water in its storage tank. As with all tanks, the hot water goes to the top. There is a thermostat located on the tank to adjust and control the water temperature. On the burner assembly, and this is going to be the same thing with a oil-fired boiler or a furnace, they're in that assembly. So basically we have a motor, we have a pump, we have a transformer, and inside two electrodes. We're pumping the oil through that at about 100 pounds PSI. We have to atomize the oil for it to ignite. We're putting 10,000 volts across the two electrodes to ignite that oil. If the nozzle is dirty and that oil is not atomized properly, we're either going to get a smoky fire or no fire. So there is a CAD cell, or what we used to call fire eye, that will shut the unit down if it can't see the flame properly. And that's why you tell people do not reset this more than once. If it doesn't fire the first time, call your oil company. Next slide, Jim. So there really is no advantage to oil besides a quick recovery rate. The disadvantages are kind of logical. The location's restricted, just like gas. You need to be able to vent the flue gases. They are probably They're way more expensive than gas or electric as far as a tank is concerned, tank water heater. They need yearly service. The cost of operation depends on the cost of the oil, and you must have on-site fuel storage. So basically, you're going to find those in areas that have limited gas and where people think they're probably better than electric because of recovery. And now we have, which is also a tank, an indirect water heater. So indirect water heaters are considered more efficient, even though they require a storage tank. They are used with the main boiler to heat the fluid that's circulated through a heat exchanger in the storage tank. If you look at the cutout there, that's the coil usually at the bottom, and we're circulating the water through there to keep it warm, and it allows the boiler to turn on and off less often, which saves energy. So with an indirect water heater, if it's used with a high efficiency boiler and a well insulated tank, it could be the least expensive means of providing hot water. Indirect systems can be fired by gas, oil, propane. I've never seen electric or solar, but apparently they're out there, or any combination of that. Okay, Jim. So the advantages would be energy efficiency by using same source for both space and water heating. They can work with any fuel fired boiler. They have 20 to 30-year useful life, which I'm going to say oil and gas, I tell people 10 to 15. Electric could go 20 because there's no direct heat. So these guys will outlast those tanks. Indirect water heaters can provide more hot water than direct fired water heaters at the same size because they have a faster recovery rate and a larger storage capacity. They can also prevent scalding by regulating temperature of the hot water. Disadvantages are they are costly on initial installation. And with any tank, you're going to have some storage losses. As the water is sitting there, you're not using it for probably 2/3 of the day, not just a day, 24-hour period, I should say. So there's always some storage loss in a tank water heater. Okay, Jim. So there's just a couple illustrations, a cutout on a tank where the coil is, and the two common types that you'll see out there. Might not be those brands, but that's what they're going to kind of look like. And they'll be tied to the boiler as a zone off the boiler. Next slide, Jim. I don't see a lot of these, but they're called booster tanks, or I refer to them as aqua boosters. So it's generally a supplement to a tankless or domestic coil to provide stored hot water by recycling the water through the domestic coil on a regular basis. So the two distinguishing features on this will be a pump. If you look at the top of that tank there, there's a pump, and then coiled in the a little towards the top of the tank is a cord. So if you see a power cord, appliance cord, and a circulating pump, this is a storage booster tank. It does not provide the hot water source. It's the domestic coil that actually is heating the water. So if your coil is failing, this will help a little bit, but eventually when that coil fails, this is not going to do anything. It's not going to be a big plus at all. And then if a domestic coil is not big enough to handle a larger family, these will come in handy. So when the coil is brand new, these work very well. If the coil's starting to wear out, this is not an end all. This is just a means to an end because it will fail. Okay, Jim. So increased hot water is one advantage, the energy efficiency by reducing the amount of hot water that is wasted through radiant heat loss. Easy installation for somebody who knows what they're doing. Water conservation by reducing the amount of cold water wasted while waiting for hot water to reach its desired temperature. Again, initial cost is a disadvantage, and storage loss in any water heater, there's some storage loss. Tankless or domestic, we see these probably quite a bit. I think we're going to see less and less of them, but so it's just a coil embedded inside the boiler. The boiler water heats the domestic water going through the coil. And the theory was to give people hot water when they need it. Why heat 40 gallons of water 24 hours a day when you're only home maybe 8 hours? You're working 8 and you're sleeping 8. So the theory was good. If they're in a steel boiler, because they usually last about 20 years, I don't know what anybody else's experience is, but 15 to 20 years, they'll scale on the outside, and you'll get resistance to the heat transfer, and they get worse and worse. I run these coils 15, 20 minutes, a half an hour. When they're bad, within 15 minutes, I got tepid water. They are theoretically replaceable. So that one on the right is a unit that can be put in to replace an old one. But there are two metal faces that gasket goes in between. If any of the face on the boiler flakes off, when you remove that, you will never, ever get that to seal on a permanent basis. It will, even if you got it to seal, at some point, it's going to leak again. Generally, most of the guys in the business that I know, they will not touch one of those. They'll always recommend the installation of an indirect water heater. Because if you think about it, if it's a steel boiler, the steel boiler's pretty much done at 20 years anyways. If it's in a cast iron boiler, you got another 20 years to go. So you hook up a indirect water heater, and you're better off than you were when you had that coil. These are typically oil and gas. I have never seen a electric boiler anyway, so I don't know if these would even be applicable if there was one. Next slide, Jim. So we kind of covered some of the advantages and disadvantages by talking about that, but the absence of a storage tank eliminates the need to purchase a separate water heater. So that's an advantage to the installer. Hot water on demand, not heating stored water 24 hours a day. So that's an advantage. If you think about it, in the summer months when that boiler doesn't need to run, we're cold starting that boiler every time we need hot water, unless it depends on how you have the water heater set. So it's less efficient in the summer months. And as I said, not always replaceable for fear of damage to the boiler. Next slide, Jim. So here is on the left, typically what you'll see. Generally, just the face you'll see with the aqua booster on it. They should have nowadays a mixing valve. I got another picture of the mixing valve in there. If you didn't have a mixing valve to temper the water or adjust the water temperature, you would have to actually change the operating pressures, temperatures of the boiler to regulate the water heater. So that's going to affect the heating of the house. So the mixing valve, if you see one that does not have one, it's probably going to be on an older install. I would recommend it. It's just a good thing to have. And it's easy for the, I'm hoping
Hey, Stan.
homeowners don't. Yes.
Stan, question. What size house? I mean, because I see some of these times, you're in a 4,000 square foot house, and I'll see this, and I call it out, is that on a really cold day, the system wants to, the way I explain it is on a real cold day, the system wants to keep you alive rather than keep you clean. So if someone's taking a big, long shower, then someone goes in for a tub, and it's 15 degrees outside. And,
yes.
I tell them, with the way the tanks are so efficient today, the storage tanks are so, thermally efficient, to get that storage 40, 50 gallons, because that might not keep up on a larger house for 3 or 4 bathrooms going.
Well, you're absolutely right. And it would be, to me, a big mistake by the builder not to provide something that can store the hot water in a larger home. So I would at least bring it to their attention. Maybe the way they use hot water, this will be fine. But I don't think it's a bad thing to at least mention it, because then if they do have an issue, they're not going to jump all over you. You know, some
Right.
of what we do when we inspect, we have to walk on eggs because, I mean, if it works, it works. If there's one person living in a house, that might provide an old coil might provide a lot of hot water for them because they're not really using it a lot. Family of four comes in, it may not do the trick. So that's why I run those things for at least 20 minutes, half hour to see if I still have a good temperature on it. But a
Good.
bigger house should have some type of storage, in my opinion.
Also, just on a side note, for report writing, you run it for 20 minutes. I know maybe some inspectors don't, but what I do for a disclaimer in my report is I'll put in that the domestic hot water supplied by a coil, the heating system may not have been run, to determine if hot water can be supplied over a long period of time, because that can happen where you're not letting it run for 20 minutes. You
Well, we
should,
always
but
need caveats to back us up.
yeah. Let me get the next screen going.
Wait, hold on. So has anybody seen that red thing on a boiler? We used to refer to it as a sidearm. It's
Every once in a
completely
while.
exposed. Yeah, so they're not that popular.
I've
but they're
never
out
seen
there.
it.
What's that?
I said I've never seen it.
Never? Well, they're not a lot.
Not one of those.
Not a lot out there. So
Right.
when you walk into a boiler room and you see that big red, looks like big can of Budweiser pipes coming out of it. That coil, the coil that we've seen before, is actually inside there, and there's an inlet and an outlet. I can't see how it's too efficient because it's standing out there in the cold basement air, but maybe that's why we don't see a lot of them. And they're
Now,
not.
is the hot water supply that big, thick pipe there on the right, or is it different? Because it looks like it's probably connected to
Yes,
the boiler, right?
it is. Yes.
Okay.
So there's an inlet and an outlet, and then I keep on wanting to point, but you won't see me. And then there's an inlet and an outlet for the domestic. So right off the bat, when I see one of those, I know they're very old because we just don't do that anymore. And I always recommend, even if I think the hot water system's working, that they should consider another means of heating domestic water, just to cover my butt. That's all. All right, next slide. So there's your mixing valve. Very similar to the one in the other picture. There's not too many of them. Just a good thing to have. And that kind of could tell. I forgot exactly when they were required to be in, but here's another thing that I've been finding, and we're going to talk about it towards the end as well. Municipalities, they vary from town to town, and where one town may say you have to have this, you may go to another town and you don't have it, so you say that. So I always like to kind of err in the side of caution, and if I don't know what a town requires, I recommend it, because at least I cover that base without looking like a know-it-all or like a building official. So I think that's one way out of putting yourself on the spot if you were wrong, and it's a good thing to have whether your town requires it or not, is the way I put it. Okay, Jim. So this Jeff, who is in attendance tonight, Jeff and I did a condo. I think it was Hamden or North Haven or somewhere up that way in Connecticut. This is an electric tankless coil. I don't have a picture. There was a cover on it. So we knew the condo was all electric. So I expected to find an electric water heater, tank water heater. And I'm looking, and then I see this box on the wall, and I'm going, what the hell is that? Because pipes are connected to it. So I pulled the cover off. So if you look in the left-hand picture, that little gray box there, yes, Jim, that's good. That's the Aquastat. And then on the left side of that unit are relays. And if you look at the right picture, you'll see the heaters. And then that whole thing in the back is a small coil. And they are heating the water with electricity. And I'm going to tell you, in 35 years, that's the one and only time that I have seen that. And certainly not comfortable with it. I forgot how old that unit was. So, it was functioning. It was providing hot water, but Jeff and I didn't take back-to-back showers. to see how long you know what I mean? But I guess if you replace if the electrical components are still replaceable, then it's going to heat. If it's not submerged in water, it's not going to scale. So, but I found that very interesting. You know, sometimes when you do this for a long, long time and things get kind of repetitive, you just enjoy seeing something that you have to stop and think about and figure out. And then after, you hope you never see it again.
I actually did a condo complex down in New Haven. There was about 10 units, and they all had these in the basement.
Oh yeah, so you've seen it? That's cool.
Yeah, I've
So
actually seen it.
you've seen 10 more than I have.
Here you go.
So now we're up to modern technology, which sometimes I like, sometimes I don't. So tankless water heaters. I guess you either love them or you hate them. There's people that swear by them, other people complain about them. But it is supposedly a quality tankless water heater, space saving, energy efficient, heating only as much water as you need at any given time. Okay, so it's basically a larger version of and separate version of a tankless coil, basically, but standalone. Okay, Jim. So they're usually gas fired. They were working on an oil fired, but they just really couldn't make it work properly. So it's on demand. The significant advantage is energy and cost savings. So the basic plumbing is very simple, but it works off of a computer that tries to determine what you're doing with the hot water. All right, are you taking a glass? Are you filling a pot? Are you taking a shower? Are you filling a swimming pool? It does supposedly produce an endless supply of hot water, takes up less space, right? You usually see them on a wall. You have a lower risk of leaking. They're safer and have a significantly longer lifespan on average. I wouldn't say significantly. All right, maybe. Upfront cost is significantly higher than a tank style heater. Let's say you had a water heater, tank water heater, and you want to go tankless, or you had a boiler that had a coil in it. Now all that plumbing's got to be moved to a wall, right? So the initial installation and moving the location of the water heater involves a lot more work than just coming in and replacing a tank. Once you have it set up, that cost goes down, right? Because it's already where it is, all the piping's there. As long as you buy a unit that's compatible, it bolts right back up, as they say. Disadvantages. They take longer to deliver hot water. Well, I think they do, because it's trying to figure out how long this water draw is going to be before it even energizes. So even with that, people love it, but that's something that they feel they don't like. So some people call it the sandwich effect. It may give you a burst of hot water and then none, and then it says, oh shit, the faucet's still open, and it tries to catch up. I never had one, so I don't know. But those are some of the complaints I hear. That's not a big deal. I hear a lot of complaints about the circuit boards, the computer, all that stuff, the electronics. And you are also using these during the winter, so they do have condensate, and that condensate can't be piped outside. You have to get rid of it from within the house. So, and then natural gas and propane applications only. So we're starting to see more and more of these, because a lot of houses are converting from oil to gas, and most heating contractors are pushing these guys. You know, you'll install 2 of these, say, in the lifespan of a quality cast iron boiler. I agree, you get a lot of heat loss from a cast iron boiler, but you'll have to do this 2 times in the lifespan of a cast iron boiler, theoretically. So if it was up to me and in my house, I would go with the cast iron, but that's me. Okay, Jim. Heat pump water heaters. I've only seen 4. If anybody attended the last class that we did on air conditioning, we talked about moving heat from one spot to the other with refrigerant. That's what we're doing with a heat pump water heater. So the black on the left and the red on the right are the on the right are the heat pumps. And what we're doing is we're absorbing heat. And if you remember, part of the refrigeration process is taking the liquid and pumping it up to a high pressure gas, which turns into a high temperature gas, and then we're heating the water with that. So it could be efficient. Let me just read what I wrote here. So the heat pump water heaters use electricity to move heat from one, and refrigerant to move heat from one place to another instead of generating the heat directly. So therefore, they can be 2 to 3 times more efficient than conventional electric resistant water heaters in the perfect environment. They forgot to put that in there. To move the heat pump works like a refrigerator in reverse. So we discussed that a little bit last week with air conditioning. So heat pump water heaters require installation in locations that remain 40 to 80 degrees Fahrenheit. Now, normally your basement is not going to get too much colder than 50, even in the winter, but it does work better in warmer environments. And it needs a lot of airflow around it. So you can't stick it in a spot, just like an air conditioning, because we need to transfer all that heat going on there. It's not going to operate efficiently in cold spaces, since they tend to cool the space even more. And installing them in a space with excessive heat, such as a furnace room, as long as there's enough airflow in there, will increase their efficiency. So you would think you would see more of them. They're more expensive, and I don't see a whole lot of them. I don't think they're catching on the way they thought they would. But at least and they also have electric heat. If you look at the one on the left, you'll see, or in the right too, but they're the same color. There's still 2 heating elements in there. So if they can't keep up on the heat pump end, you're going to energize electric heat anyways. Very similar to a heat pump around here. If we can't keep up in the 30-degree temperature outside, then your heat pump's got to rely on emergency heat, which is electric. So same principle here. Okay, Jim. So again, I got a little ahead of myself, but the advantages are they're energy efficient, constant availability of an energy source, right? You won't, as long as you have the electricity and you don't have a freon leak, it's going to work. They've actually been used to heat radiant floor and jacuzzis and swimming pools. So they're versatile. They can be used with other water heating systems, and they're low operating costs, so they say. Energy is lost with low ambient temperature as a disadvantage in the high purchase cost and installation cost.
I've seen them installed in hydro systems where rather than a boiler, they're using the water heater. Pump hot.
Yeah, but I've seen electric water heaters that, I mean, look, it's worth a try. And you need some time to determine if that's going to work. If you put everything together in a lab in the perfect environment, it's going to be, yeah, it's great, but you got to put them out there in all different situations and see how they go. So I just don't think they're taking off as they thought they would, because I'm not seeing a whole lot of them. I guess they're cost prohibitive. So I don't know how many guys test the hot water when they're doing their home inspection. Here's a little chart. Tells you when the water temperature is 120, you have to have your hand under there for more than 5 minutes to get a serious burn. And then as we go up the temperature chart, it's less and less, right? So we're always worried about kids turning on hot water and getting scalded. Well, some adults too, but kids don't have an excuse. They don't know better. Years and years ago, there was it wasn't in Connecticut, but there was a story of a lawsuit where a woman was in an apartment building, she put her baby in the sink, first of all, to wash it. She didn't turn on the water, but her toddler came in and turned on the hot water. By the time she got back, the baby was scalded. She sued the apartment building, the water heater manufacturer, and the people in charge of maintaining the building. When it was her fault, in my opinion, to put a baby in the sink to begin with, unattended. But that's why we started getting, anti-scald devices and things of that nature. So I I don't go to the next slide, Jim. That's me on the right. I don't use a thermometer. The initial blast of water, remember we talked about water stratification, the temperature stratification of water. It's going to be hotter than what your thermostat is set at right at the top of that tank. And that's the first blast of water that comes out of the tank. So if you're going to take water temperature, you really need to let that water run a little bit to get the actual temperature of the water heater, that center mass water. So I just use my hand. I don't tell people numbers. If I think it's very hot, I'll put water heat temperature should be adjusted. But I don't put any number. I try to stay away from numbers. I don't want to lock in on anything. So I think it's a good idea to get some kind of idea how that thing's running, because you need to know if it's enough. But if it's high, I think it should be mentioned as well, just for protection for us common home inspectors. So some visible defects. Well, if you walk into a basement and you see that, do you know if it's the water heater or the pressure relief valve that released? I don't think you need to know. I think you just need to call it out, right? If you don't see a big mess like that, it's still not a bad idea if the tank is up off the ground to just peek underneath it. A couple times I caught some dampness under a tank that might have saved me some money, or at least some explaining. So this is a dead giveaway of a problem, but we're not going to see that every day. Next slide, Jim. Melted rings on a gas water heater. Has anybody come across that?
Yeah.
Yeah.
So a couple issues. It could be poor combustion air in that room, confined space. The other thing it could be, if you look at the configuration of the piping in the bottom picture, the pipe I should have gotten a picture from farther away, but the pipe on the left is the water heater pipe. The pipe on the right is the furnace exhaust. Let's say that the water heater's on and the furnace comes on. Furnace pipe is bigger. It's gonna, upon initial startup, probably gonna blow a bunch of exhaust through there, and it's gonna push the heat momentarily back down through that open draft hood. And after so many times, it's going to start melting those rings. It's an issue when I call it out.
Stan, isn't that a T connection? Isn't that incorrect? Should be a Y connection.
It's supposed to be Y, or they recommend a Y. I say that's not the best way to handle it. There's other configurations, but when you walk into so many houses that have that, you're fighting against a profession that does that on a regular basis. I know. So I never make a statement that says I know more than them, because I don't install those things anymore. But I also tell them there's a better way to do this. And I tell them that this is a potential safety hazard and they need to have somebody come in and determine how that's happening. Right. So I did my job. I don't go back and ask them how they made out. I just write it up. So this is only an oil fire. When that tank was brand new, that pipe was dead center of that cutout. And as we fire into the firebox, we are weakening that box after time. And we have 30, smallest oil fire tank I've ever seen was 30 gallons, 8 pounds a gallon of water. So we have 240 pounds sitting on that tank. As it gets older, that tank is going to compress. It's going to just get squished, and that pipe moves. Now, tank might not be leaking, and we might have some problems inside the tank, because if you look at the bottom picture, as that tank is compressed, then the flame pattern the flame on an oil fired, whatever, could be boiler, water heater, furnace, fills that firebox, but should never touch the walls. And as that box gets smaller, it starts impinging on the box. We get that scorching coming out that inspection plate as well. So even if that tank is functioning, those are signs that it's close to failure. If you see that, you really should note it.
Is that a plastic extension too there?
Yeah, but that's not for this picture.
Okay.
Just combination of problems there, but we're only talking about the compression of the tank and the displacement of the pipe and stuff like that. So if you see that, even on a functional water heater, write that up as at the end or exceeded its useful life. I shouldn't say that. Not exceed. Doesn't make a difference how old that tank is. That's a problem. But usually it's in older tanks. Here's a common one, right? No drip leg for the pressure relief valve. You know, so they face them to a wall where nobody should be standing. And in this case, they couldn't even put one on because if you look at the ball valve, the handle is in the way. So they didn't want to make any adjustments to anything. They just didn't put the pipe on there. But it really should be on there. It is a potential safety hazard. I think we would all agree on that. And I've seen the gas company put brand new water heaters in when they used to, and not put a drip leg on the relief valve. So
you can use PEX too, can't you?
PEX on a relief valve?
I've seen it all the time.
You can use for the hot water.
Yeah.
But it's supposed to be strapped. So any plastic pipe is going to flail. Right? When you got pressure shooting through there, it needs to be strapped to the tank. How many times have you seen a plastic pipe strapped to the tank?
Never.
0. Maybe once or twice. Now, I could say, well, who's going to be standing down here? What's the chance of that happening? And they're standing down here. Always a chance. So, but in this case, it's the not having one is the issue here. There's another picture. Go ahead. You can. So too short is better than nothing, right? It's still not going down to the ground. You should really call that out just to protect yourself again. You could go on, Jim. So this is the same picture, but now it's because we don't have it secured. And I'm going to tell you that a very small percentage of the plastic pipe I see, I can identify as CPVC or PVC. Now, with PVC, we're not containing that water. We're shooting it right through. I'm not 100% concerned if it's PVC because we're not holding hot water, but PVC is not designed to carry those temperatures. So that's why people call them out. See here, every 3 inches, they're supposed to be strapped to the tank. Pressure relief valve dripping. You may not know what the problem is, but certainly should be called out. It's either overpressure in the tank or the valve is either stuck open a little bit or just tired, needs to be replaced. I love these. You know, whether it's ductwork, piping, condensate, for every 90 degrees, you're cutting down the flow of air or water tremendously. And most of these valves will tell you, I think it's two 90s. So the problem is if you are undersized, I didn't have a picture of undersized, but so if it's 3/4 inch outlet, it's got to be 3/4 inch pipe. If you go smaller or you got too many elbows, you're going to hold back the exit of that pressure and you can still damage the tank. All right. The other thing is that you're supposed to go to daylight. So that if you're passing by a tank or you're doing laundry near a tank, you need to see the relief valve so that if you notice water coming out, you know there's a potential problem. When it goes someplace else, you don't even know if that tank has a problem. So theoretically, those should be called out. Now, both of those are in condos because that's what condos do.
Is there any workaround on that?
Condos, so the workaround, the building department passed on that. right? Probably,
So
I
if
don't
it's in
even
a
know how many
condo,
units were.
so if in
Every
condo, you
unit,
don't need a disclaimer then, huh?
I don't know. Building department scares me a lot of times.
Right.
Because
Well,
the
so-
condo association did not want that water dumping if something happened into their condo. If that's second floor or even third floor, then
But
everybody
then there is a
below that.
workaround, right? Like, what do you like if you're going to recommend something different, or if someone asks a question about like, oh, well, how do I do this different? Then like, what would you tell them? Because if that's the way they put it in, then that's kind of just
Right.
it, right? Or would you
That's
tell them to just
that's
put
the conundrum. Like, do you mention it? I always say, I always tell people, look, this is not the right way to do this, but if the building department signed off on it, it's going to be hard to fight City Hall. And
But
in
you
a
could have a
condo,
situation. You could have a situation where this thing is got too much pressure. It's bleeding out of the pressure relief valve extension, and you don't know it because you can't see water.
that's what I'm saying.
right.
So
So me personally, I'd rather have water in a unit below me than to have that thing blow up in somebody's house.
you could have it
But
go down to the pan and then put an alarm.
there is a pan,
Yeah.
so
All right.
pan's not going to hold the water in that tank. If it just lets go, it'll catch drip. Pan's not gonna, if that relief valve blows off, I had it happen in my basement. A pan's not gonna catch the water that comes out of a relief valve. It's just too much. So, but these are the things you're gonna see, and you gotta figure out how you wanna handle them. So galvanic corrosion, we all know about that in piping, but that's probably one of the worst ones I've seen. And how does it even get that? Does anybody walk by that water heater ever? That's pretty bad. And what's happening is it seeps, it corrodes, it seeps, it corrodes, it starts to almost act as a patch. And then that whole thing's now got to be replaced, right? You can't salvage that valve. Why you have a union on that anyways? So that was a mess. Rusted tanks, no matter where the water's coming from. So I wanted to point again. So you see that little rectangular thing in the upper left-hand corner? That's a cover for a element, and the water was leaking out where the element fits into the tank, but it was also coming from the top. So that tank basically was shot. I mean, if you want to go until your basement's flooded, go ahead, be my guest, but I call for a replacement. This isn't a really good picture, but remember we talked about if a coil is rusted and they take that front plate off, you can actually see the gasket in there. If that's rusted and they take that gasket off to replace it, and even a tiny piece of the rust flakes off the inner portion of that coil, or that sleeve, it's going to be hard to seal that on a regular basis. It's going to be a big problem. So a lot of guys just cut the inlet and outlet out, and when those coils fail, and then put the indirect in there. So now these are not so unusual observations. That's a 40-gallon electric water heater in a ceiling of a converted school that was converted to condos. I guess they didn't care how it was going to be replaced or if it leaks, but that's where they put it. They wanted more living space, so they stuck it up in the ceiling. And then here's what I call the portable water heater. In some places in the United States, this is acceptable, right? That's just an appliance cord plugged into a 220 volt
That's
receptacle. So I've never seen that. I stole that picture. Sorry. I want to put it in there though. And then around here, anyways, we have the rented water heaters.
100-gallon.
80 to 119 gallons. And if you want a bigger one, we'll make one for you because we're making a ton of money off eating all that water. So people like the fact that if it fails, it's replaced. For years I heard that the program was defunct, but there's new ones now. They're white. They're still doing it. I think they've revived because we're eliminating. We just want to go green, right? So I think they just put it back out there, but that's a lot of water to heat. there's nothing wrong, right? If the tank's not leaking, maybe that strap should be.
I still see these, and
extra.
it's amazing that they last this long.
What?
There's some
Yeah,
of
electric?
there's some of these that from the programs from the 70s, and these water heaters are still going.
Yeah, I mean, if you put money into the design, I mean, we don't have any direct heat, and it's designed properly, and the anode rod works. I mean, they should have some longevity, but you know, I tell people, look, there's options to that if you don't want to heat all that water. Now, we're back to the Navion here. So, in another class or seminar that I was at, there was a contractor who said that and it's true, that the condensate from a high efficiency boiler, furnace, or water heater is acidic, and it really should go through a neutralizer. Okay, and he said it's code. I hate that word. Now, maybe the manufacturer recommends it, and maybe some municipalities require it, but in all the new construction that I've done since that seminar, I've rarely seen the neutralizers. I recommend them. I don't say you have to have them. I recommend them. Again, to cover my butt. So the last thing here is just this kind of summary of things that you may see that would tell you that the water heater may not be working properly. So you might see dripping water, even if it's from piping and stuff, pooling or underneath the unit, valves that aren't fully closed, or connections that are loose, components that need tightening or replacing, which are easy fixes. But if the tank is leaking, obviously you need to replace the water heater. Okay, Jim. Age of the water heater. You know, none of like, for instance, Connecticut doesn't say that you have to tell somebody how old something is, but you also have to tell them if it's old and at the end of its useful life. So I always make an effort to try and age the unit, either through the serial number. A lot of times it says manufacture date. If not, I tell them to try and determine the age so they can extrapolate the remaining useful life, just to protect myself. Running out of hot water quickly, a bunch of things could be wrong. Thermostat, could be the drip tube. But again, if you run the hot water for any length of time and it's gone in 5 minutes, there's a problem. It could be even the sediment build up in a tank if it was never drained. You know, you're supposed to drain your tank once a year. Has anybody done that? Not me.
Yep.
Sorry. So, inconsistent water temperature in the shower could be the thermostat. Well, you're not going to be taking a shower. That's just for the homeowner, basically. But is there another one, Jim?
That's it.
Discolored
right
water.
there. Low
And water
pressure.
So if you got rusting water, you got a problem someplace, right? Could be the water heater. First thing I would look at, especially if it's on a hot water side. And then lower water pressure on the hot water side could be that sediment that's creating problems within the hot water piping. So rarely do I see that, and you can't distinguish when you're there, but that is something that should tell you to make some type of call when you're reporting on it. So very simple component and a very simple system, but you still got to keep your eyes open and pay attention. There's still a lot of things that could go wrong.
Hey, Stan, couple questions. You on the newer water heaters, they're saying not to insulate them because that will void the manufacturer's warranty.
Well, you'd have to. So they're supposed to be insulated already. There's an insulation between the jacket and the tank.
Yes, but you'll have people put like a blanket.
Right, a jacket.
over it. Yeah.
When I see them, I'm telling them it does nothing. It's already
Okay.
insulated, and you know, you want to, you know, even using a tube of caulk or a can of paint, if you don't follow the manufacturer's recommendations and it fails and it causes you damage, and they can prove it, you're done. Most people aren't going to read anything that comes with their furnace, heating system, water heater, whatever. They
Right.
really should, because they need to know what not to do more than what to do.
The other thing I see a lot is PEX connected directly to the water heater, my understanding is you need at least 18 inches of copper.
Yes.
Okay.
Do you think you need that for electric?
Yes,
We don't have any combustion. We don't have a hot pipe going through the middle of those two pipes.
that's what my understanding is.
Okay. Well, it's less of a problem with electric, right? Because we don't have a flue
Right.
right there. But if I
Uh,
see that, I tell them that it's probably not really the best way to handle this and to have a plumber. But what if you tell them to have a plumber come and check it out and he goes, that's fine. You're still covered because you brought it up.
So, a couple of questions we have. Well, on an electric water heater, the Romex needs to be in a conduit, right?
Yeah, it should be.
Okay.
But I see it awful lot just draping down. It's a nicer install. It protects the Romex,
Right.
right? What about
Yeah.
seal tight? You know what seal tight is? The plastic, the flexible plastic.
Yes.
That's protection as well. We use that on
Okay.
the outside on radon systems. So
The other questions we have: life expectancies of water heaters, electric, gas, oil. Can we just go through that and then we'll end the
So-
seminar?
I'm going to tell you what I tell people. All right.
Okay.
If you Google, you're going to get a variation of all of this. I'm trying to be fair, and I base my opinion off of what I've seen in 35 years. I see oil fired water heaters go 12 to 15 years. All right. They may go longer, but they'll look like that blue one and the,
Right.
gas water heaters, I'm saying 10 to 15. That's what I see. Now, there's a couple like the old GEs, they look like bullets. They were 30 years and running, right? Electric water heaters, I say 15 to 20. But if you went to Home Depot and you saw their display at one time, they had the 1-year warranty tank, the 5-year warranty tank, and the 10-year warranty tank. You're not going to get 15 years out of that 1-year warranty. I don't even know why you would buy that unless you just wanted to replace a water heater to get out of a house. All right. So you also need to know what the warranty is on there to judge the quality of that water heater.
So, in your opinion, electric water heaters last longer than oil or gas?
Yeah, there's no direct heat on the bottom.
Okay.
So they seem to look. Water quality affects it. If you're talking about well water, different ballgame, right? But that's what I've seen over the years. Can they fail earlier and last longer? Sure. If you have 100 light bulbs in a perfect environment, 10 are going to fail early, 10 are going to go longer. When the 80 in the middle fail, that's what they say the useful life of that light bulb is. So you always got the short and the long.
Another question. Can you re-explain hold on one second, because I'm having trouble reading this. On indirect water heater, do indirect water heaters include a circular pump? And can you go over the reset button cautionary? Don't do it twice.
Let me start with the reset button. If your burner, whatever it's on, is trying to fire and it doesn't fire, it either didn't see the flame or the flame was smoky. You can reset it. If the same thing happens, you may be dumping oil in there. And if you keep on resetting it, eventually it may ignite, but now all that wet oil that's not atomized will you'll have smoke throughout your house. So they say, if you try it once and it doesn't ignite, at least most of the oil guys I know, they say, call us. We're going to tell you to try it one more time. If it does not ignite, we're going to come to your house. The reason why they're saying that is if you don't have them on a service contract, it's going to be a very expensive proposition. So if it runs, they'll say, we'll come in the morning when we're on regular time. If we come at night, it's going to be emergency. And you make the decision at that. If it runs, you'll say, yeah, come in the morning. If it doesn't, you may tell them to come right away. Gotcha. But you could create a bigger problem after that. And as far as a circulating pump, that's a good question because I'm going to say that not everyone has one. But, unfortunately, I don't know the answer to that 100% right now. we could send an email out and I'll double check.
Yeah, we'll send an email out. Okay,
Any other
very
questions?
informative, very informative. Thank you very much, Stan.
Thank you. Thanks for coming.
Yeah, I'm gonna end the seminar. Our next seminar is electrical, and I will send out information on that, and you will get your certificates tomorrow morning. All right, thank you.
Okay, gentlemen, have a good evening.
Thanks.
Take care.